Hi everyone, welcome to Practical Electronics. In this tutorial we're going to look at the fundamentals of electronics as well as some electronic components. First, let's look at some definitions. Electricity is a form of energy that involves the movement of electronics from one point to another through a conductor. It has a number of properties that we can use for measurement, most notably being voltage, current, and power. Electronics is a field of engineering that deals with controlling electricity at a small scale in order to achieve a large number of desired functions. Voltage is electrical pressure that pushes charges through a circuit. It is also known as potential difference. The symbol for this is V and it's measured in volts. Current is the rate of flow of electric charge past a point. It's perceived to flow from a more positive point to a negative point. The symbol for this is I and it's measured in amperes. Power in an electrical circuit is the product of the voltage applied to the circuit and the current flowing through the circuit. The symbol for this is P and it's measured in watts. How exactly is electricity generated? There are many ways to generate electricity, but they all center around the principle of changing energy from one form to another. The most common is converting motion to electricity. This is done by turning turbines either by using steam, water, or wind. Another popular method of generating electricity is by converting solar energy to electricity. Electricity is transported over far distances at high voltages in alternating current format. This is current that changes its direction at regular intervals. Transformers are used to step down the high voltage to usable levels within the home. Electronic devices make use of step-down transformers to lower the voltage even further to a level safe enough for use. Now let's look at a power source. A power source is the means of providing power to electronic devices. Power sources may be alternating current or direct current. AC power sources are good for household appliances but will require conversion to DC in order to power electronics. Most devices have power supply circuits that do this conversion. DC power sources may also require the voltage to be modified at different levels. This process is called regulation. The design of a good power source is the starting point of all electronics design. Let's look at conductors. A conductor is a material that has the ability to carry electrical current. Some conductors are regarded as good conductors, meaning that they can carry electrical current with minimal loss to the voltage. We'll get to this at a later stage. Poor conductors have poor current carrying capacity. Copper is regarded as the most popular conductor in electronics. Conductors whose properties may be changed by external factors are known as semiconductors. And now we get to electronic components. First up is a resistor. A resistor is an electronic component that resists the flow of current. They come in various shapes and sizes, both physical and in value. Resistance is measured in ohms. The higher the resistance in a circuit, the lower the current that can flow through. Resistors are used to control the flow of current in electronic circuits. On the bottom right, we can see the symbol for resistors, as well as the formula used to calculate resistance. In this image, you can see examples of some real-life resistors. Next up is the capacitor. A capacitor is an electronic component that serves a few functions. Capacitors have the ability to store electrical charge, and they have the ability to also dissipate this charge. Capacitors have a resistance that is dependent on the frequency of the voltage that is applied across their terminals. They have high impedance at low frequencies and low impedance at high frequencies. There are various types of capacitors with different properties. The most common are ceramic capacitors and electrolytic capacitors. Capacitance is measured in farads. Capacitor values are usually in the micro and nano scale. On the screen you can see some icons for capacitor as well as the formula used to calculate capacitance. In this image you can see an example of some real-life capacitors. Lastly, we're going to look at the diode. A diode is a semiconductor component. Diodes allow voltage to flow only in one direction from one terminal to the other, while resisting the flow of current in the opposite direction. In this instance, a diode acts like a valve. Current flows from the anode to the cathode. This is because resistance from the anode to cathode is low, while resistance from the cathode to anode is high. Some important information to note for diodes are the markings of the anode and the cathode, as well as the voltage drop across the diode, which is typically 0.7 volts. In this image you can see some real-life diodes. On this image, I've added another type of diode which is popularly known as LED, a light emitting diode. Now we'll look at electronic circuits. Electronic circuits are a combination of electronic components that follow design principles to achieve a specific function. Circuits may be as simple as controlling a light through a power source and a switch to controlling transmission of signals over great distances. A circuit requires a power source in order to function. The voltage applied to a circuit by a power source gets used up by all components within the circuit. Current flows from a positive terminal of the power source to the negative terminal. Current prefers the path of least resistance. On the screen we have an example of a simple circuit that operates an LED. Let's look at component arrangement. Components can be arranged in series or in parallel to make up a component of a different value, which could be either bigger or smaller. Series means components are connected in line with one terminal from one component connecting to the next. Components that are wired in parallel are connected such that each of their terminals are connected to one another. In order for us to do electronic design, we have to understand the mathematics behind electronics. Ohm's law describes the relationship between the voltage, current, and resistance in a circuit. Voltage across a component or a circuit is the product of the current flowing through and the total resistance. In a more practical setting, the voltage and resistance will be known. This equation can then be used to calculate the current flowing through the component or the circuit. In similar fashion, resistance can be calculated by swapping the variables around. You can easily remember this by making reference to the triangle on the screen. For resistors in series, the total resistance is the sum of all the resistors in the circuit. When they are in parallel, we use the formula that's shown on the left to make the calculation. The opposite applies for capacitors. For capacitors in series, we use the formula that's shown on the top right of the screen. When capacitors are connected in parallel, the total capacitance is the sum of all the capacitors in the circuit. Let's look at some examples. For resistors connected in series, the total resistance is the sum of all resistors in the circuit. For capacitors connected in series, we use the formula shown on the screen, and the total will be a factor of each of the capacitors. When resistors are connected in parallel, we use the formula that's shown on the left side, and this calculation is simple if resistors are of the same value. For capacitors in parallel, we use the formula that's shown on the right side of the screen, and the total will be the sum of the capacitors that we have in our circuit. Let's look at some main points to summarize. Electricity can be quantified using voltage, current, and power. Electronic components are used to control electricity based on their different properties. Resistors resist the flow of current. Capacitors store and dissipate electric charge. And they have a resistance that is dependent on frequency. Semiconductors have properties that are variable. Diodes are the simplest form of semiconductors that allow the flow of current only in one direction. Electronic components can be arranged following design principles to produce a circuit that achieves a desired function. A circuit requires a power source in order to function. The voltage supplied to a circuit gets used up by the components of the circuit. Now we are ready to start building some electronics. Thank you and see you in the next videos.